All right. Hello again, Anna, Rezi, and Jonathan. So for today, anong gagawin natin? We'll continue our discussion about some big theorems about sequences. But before that, I was reviewing kanina yung recording ng klase natin para malaman ko kung saan tayo tumigil. Actually, kasi nakalimutan ko. Yung pala, super putol-putol ako sa dulo. So kindly let me know if I am not kung napuputol yung sentences ko due to due to unstable internet connection, so I can repeat what I said, especially if it's in the middle of a proof or a very important concept. All right. And then I also I think that I already graded all of the problem sets as of when. Kailan ko siya natapos? I think I finished it last either yesterday or Sunday. So if you submitted and I haven't returned it to you yet, most probably natabunan siya sa email, especially for those who had troubles uploading it in Canvas. Everything in Canvas is graded na, but kung na-miss ko yun sa inyo, paki-email ako so that I can get back to it and grade your work. Okay. Kindly take a look at my comments on your work and see kung paano nyo may improve yung mga solutions nyo, hopefully in preparation for the next problem set. So, nakumusta ko na ba kayo last time about how you think the problem set was? I really would love to get your comments para ma-adjust ko if ever yung susunod na problem set. Okay, good. Pero malamang Rezi, hindi kayo nag-comment, no? So kasi kung walang comments, I'll maintain the same I'll maintain the same level or the same length for the next problem set. So unless there would be some reklamo or qualms from you guys, I'll keep the pace like that, okay? Or I'll leave the what I call this. I leave the format like that. Tricky po. Okay. Naalala ko na Jonathan. Nagreklamo si Jonathan. Hindi pala yung reklamo. Comment ni Jonathan ay masyado daw tricky. Yeah, and I hope you see the reasons dun sa true or false. Medyo nung sinulat ko rin siya, actually yung iba ay inspired by some of the problems in one of the books I'm using. Yung sinasagutan ko siya, lalo na yung hindi ako yung nag-imbento, nag-isip din ako ng matagal bago ko siya nasagutan, and hopefully tama yung explanation ko. So if you disagree with me, just let me know and then tingnan natin, all right? But I think yung one question a day. All right, yeah, I'll always maintain I'll maintain it that way. Yeah, at most one question a day. Kung 4 problems, I'll make it 5 days, 5 working days. Hindi ko ibibilang yung weekends. Kung 3 questions lang yung susunod, then I'll give you 4 or 5 working days to finish it. All right. Okay. So and then what else? Ano pa nga ba? Oh, I think that's it. All right. So actually, marami na pala tayong napag-usapan. Ito dapat yung segue, first 10 minutes ng klase. Wag muna tayo mag-start. Just to be comfortable with each other muna para chismisan muna, right? So what I was thinking is, dahil minsan walang nakikipag-usap sa akin pag sa simula ng klase, I thought of the first segment of the lecture will be sort of sharing my random thoughts. Okay, so yun yung naisip kong gawing introduction. Over the weekend, of course, dahil medyo pasaway din ako, I'm still reading some I still lurk in the comment sections of political posts. All right, kahit sabi ko nakaka-stress pag minsan. Pero there are times that you'll read the post and then you'll feel inspired, okay? Kaya sabi ko, sige, mukhang worth it naman na magbasa, all right? Kahit matitrigger ka or kahit medyo sasama yung pakiramdam mo. Pero if you see a post that is so heartwarming, forget about the name of the particular candidate or party. Maano ka, ma-inspire ka, magkakaroon ka ng motivation, magkakaroon ka ng pag-asa, right? But there are still some posts na medyo hindi mo matatanggap and triggered ka. And some of them reminded me of this article or this meme that I saw a couple of years back kay Facebook. This is about the US military trying to improve their planes, okay? So ang idea rito ay Second World War. Tapos usually sa mga wars between countries with almost equal footing as far as technology is concerned, yung victory sa war is oftentimes dictated by yung survivalship ng kanilang mga Class A weapons or the way they or name-measure siya kung sino yung makakapag-provide ng needs or ration ng kanilang army or troops on the ground. And that's why the Second World War birthed some of the modern mathematical tools like operations research. The modern OR, as we know it, is a product of the Second World War, where the British and the Americans are trying to improve their processes, pag-provide ng services or supplies sa kanilang mga troops on the ground. And one of the problems during the Second World War, ito naman ay sa US, pinag-aralan nila, paano kaya natin may increase yung survival rate ng ating mga airplanes? Of course, if you want to build a sturdy plane, ilalagyan mo ng armor, lalagyan mo ng reinforcements yung parts ng plane. But of course, you cannot envelop the entire airplane with these metals or these materials kasi masyado siyang bibigat. Hindi naman siya makakapag-perform ng maayos. Magkakaroon ng drag, etc., etc. Okay? Magiging mas susceptible siya to enemy radar and so on. So what they did is pinag-aralan nila yung mga planes nila na galing sa enemy territory, and they mapped out yung mga common areas kung saan itong mga airplanes nila ay na-hit ng enemy bullets. Alright? So isa sa mga isang typical result ay nandito sa slide natin. I hope you can see my slide. I'm sharing my screen here. So yung mga red dots yan yung mga bullet holes. Alright? Tapos ang initial assessment ng mga generals o ng mga nasa military is, okay, what if i-reinforce natin itong yellow portions ng airplanes natin para hindi sila magkaroon ng bullet holes, right? Para mas mapataas yung survivorship nila. However, there came this mathematician by the name of Abraham Wald. Sabi niya, hold on, may flaw yung reasoning nyo na yan. And can somebody guess ano yung flaw dun sa reasoning nung initial dun sa initial assessment ng army o ng military? Ito yung sinasabi ng mga speakers natin sa SAF nung 2 weeks back, no? So mathematicians, we are trained to think outside the box, all right? So conventional wisdom, nakita nung mga nasa military na dito tinatamaan ng bullets yung ating mga planes. So ito yung patsihan natin ng reinforcement o ng armor, right? Pero merong isang mathematician that thought out of the box. Ito yung idea niya. Wala yatang hula. Sabi niya ay, mali yung analysis nyo. Yung mga planes na nakabalik ay nag-survive exactly because the bullet holes occurred at this area. You fail to consider yung mga planes na hindi nakabalik kasi tinamaan sila sa mas importanteng part ng engine, or part ng plane. Specifically, say the engine, or somewhere here between the main body and the tail. All right? So, dapat ito yung i-reinforce nyo. Okay? Kasi ang napakita nung study ay nakakabalik naman yung mga planes na dito nagkaroon ng bullet holes. Yung mga wala dyan, sila yung mga hindi nakabalik, malamang tinamaan sa parts other than those with the bullet holes dun sa mga survivors. So this is what we call the survivorship bias, or the survivorship bias, or the immortal time bias, wherein in a particular study, we often take a look at the characteristics possessed by those who survive a certain selection. So parang anong nangyayari, kung sino yung mga naging successful amid some events, sila yung tinitingnan natin as a model for everybody in the group. But oftentimes, we forget to consider those who were not lucky or fortunate enough to have survived the certain event, because their demise might have been caused by some lacking characteristics that those survivors do not possess. So we will be deemed to repeat history or the tragedy of history if we will just keep on modeling our ideas or our opinions from on the basis of those who survive. Paano naman yung mga hindi na nakaabot sa panahong ito? They do not have the voice to express what happened to them. All right? And if we will not listen to this unheard voices, or if we will not try to dig deep to hear this unheard voices, then we are doomed to repeat the tragedy. All right. So hindi lamang applicable sa research o sa hard sciences research like sa clinical trials and so on, but even in our daily lives. So yeah, some food for thought for you to to think about, to ponder about. And the nice thing about this, ano siya, brought about by a mathematical idea. So sana wag tayong maging victim o maging what do you call this? Maging guilty of survivorship bias. Okay? So that's my random thought for today. So back to original programming. Okay. So last time we were talking about order theorem for limits, I think, and then we came across uh, yeah. Yeah, an equivalent statement for actually hindi tayo natapos sa order limit theorems. We started talking about subsequences. Sabi natin, yung mga subsequences, ito lamang ay isang sequence na nabuo mula sa isang parent sequence kung saan pumipili tayo ng elements mula dun sa parent sequence pero pine-preserve natin yung order. Yung isang nauuna dun sa parent sequence, hindi siya pwedeng maunahan doon sa subsequence because we will preserve some sort or to some extent the order dun sa parent sequence. All right. And then the convergence of a sequence is intertwined with some convergence properties of each of its subsequences. All right. And that's what we have in Theorem 2.6. So dito tayo tumigil last time. Di ko sinimulan yung proof ng Theorem 2.6. But this is an equivalence statement, right? Meron tatlong statements and the theorem claims that these three statements are equivalent. So, ibig sabihin, we are to prove three biconditional statements here, right? Because we need to prove A if and only if B if and only if C, and if and only if C. All right? Pero sa Math 101, natutunan natin may shortcut yan. All right? So, pwede tayong bumuo ng sequence of arguments na pwede nating gamitan ng hypothetical syllogism, right? So instead of proving three biconditionals, which in turn will be equivalent to proving six conditional statements, pwede natin yung makalahati and just prove three conditional statements. And we can do so by trying to see if we can prove A implies B implies C, and C implies A. Kasi kung ma-prove natin yung cycle na yan, ibig sabihin, we can also conclude that B implies A. Ipo-prove natin yung A implies B. Pero si B, i-imply pa rin niya si A via hypothetical syllogism. Because B implies C, and we'll also prove that C implies A, so in turn, B will imply A. Right? So nabuo na natin yung A if and only if B. Ganun din yung mangyayari dun sa ibang implications. So from six conditionals, pwede na natin ito ma-prove by just writing arguments for the three conditional statements. So na ganito natin siya i-design. Okay? Of course, you can jumble the order. Okay? Pwedeng A implies C implies B. Okay lang din yon. Alright? Basta meron kang isang cycle. Alright? Now, ano yung statements na gusto nating paglaruan in this statement? First statement is A sub n converges to a real number A. Okay? Tapos, equivalent daw siya kung lahat ng subsequence ay nagko-converge kay A. So this is a very powerful result na kapag ka meron kang sequence na nagko-converge kay A, that will happen if and only if, okay, lahat ng subsequence nung A sub n ay magko-converge to the same limit. And remember that because it would be our source for a divergence criterion later, okay? And then equivalent to this previous two statements is the fact that the even subsequence and the odd subsequence, so when I refer to those sequences, ibig ko lang sabihin ay yung subsequence form nung lahat ng may even index, tapos yung subsequence form by those na may mga odd indices. Alright, sorry about that, guys. Nawala yata ako doon, no? How about now? Okay, there you go. Sorry about that. Saan ako naputol? Hindi ko na maalala. So, narinig ba yung explanation ko kung bakit obvious yung B implying C? Or hindi? Ulitin ko doon? Alright. So, mukhang na this all right. Thank you, Charles. So, but I think I explained how the proof or how our strategy to prove the equivalence work. Kailangan nating i-prove yung tatlong biconditionals at yung tatlong conditionals lamang. All right. Now, the part where B implies C is a little obvious. Actually, hindi a little obvious, pero very obvious. Kasi yung statement B, siya yung magiging assumption. Okay? Tapos, ang gusto nating i-prove yung statement C. Right? Ano ba yung sabi ni statement B? Sabi ni statement B, every subsequence converges to A. So we are forced to assume that any subsequence of AN will converge to the number A. And using that assumption, we want to show that the even and the odd subsequence will converge to A. But these two guys, the even and the odd subsequences are subsequences. They are specific subsequences of the parent sequence A sub n. All right? So ibig sabihin, by assumption, magko-converge na kagad etong dalawang ito. All right? So kaya sabi dun sa text, yung B implying C ay obvious. Kasi specific subsequence lang itong dalawa, ang assumption kay B, nagko-converge kahit ano pang subsequence yon. So statement C is just an instantiation of statement B. That's why it's very obvious. Okay? So I hope that's fine. So okay na to, yung B implying C. So down to two conditionals. We want to prove A implying B and B implies C. So let's do the first one, A implying B. So for A implying B, our assumption is that the parent sequence is converges to the real number A. Okay? So, ito yung proof niya. Halos 2 lines lang yung ginamit. And let's see how it is done. Okay. Now, of course, ito yung assumption natin, statement A. Oops, sorry. Masakit sa mata yung highlighter. Okay. So, ito yung assumption natin. Si AN ay nagko-converge kay A. Statement A. Gusto nating i-prove na kahit ano pang subsequence ang piliin natin, magko-converge siya dapat kay A. Alright? So what I'll do is to first apply the definition of convergence dun sa parent sequence, which is usually the case. So pag nagsusulat kayo ng proof tapos hindi nyo pa sure kung paano siya paano siya isusulat, it's a nice exercise to first dissect what each of the assumptions are telling you. Right? So pwedeng sa isang papel, halimbawa katulad nito, ang assumption ay si AN ay convergent, write down what you know from convergence. And of course, we will start from the very basic one, yung definition ng pagiging convergent. So when you say A sub n is convergent and it converges to the number A, then for any epsilon you can think of, there exists a natural number n such that starting from capital N and so on, the distance between the terms in the sequence in A is less than epsilon. Okay? Yan yung manggagaling dun sa assumption. Pero anong gusto nating ipakita? Gusto kong ipakita ng isang arbitrary subsequence ni AN ay nagko-converge din kay A. So ultimately, I know that my goal is this inequality. Dapat yung A sub nk minus A ay less than epsilon for some starting index para kay nk. Alright, so starting from some point, this inequality will be true. Kasi yun naman yung definition ng convergence sequence applied to the subsequence A sub nk. All right. Now, we need to take advantage of the previous idea that we have. All right. Una, sa definition, meron na tayong starting index. Probably, I'm guessing that this starting index will be related somehow to the starting index I'm looking for the subsequence. And true enough, there's remark 2.4 na sinasabi yung Kate index doon sa subsequence, alright, ay laging greater than or equal dun sa Kate index doon sa parent sequence. Alright? Kasi yung subscript na K, hindi siya pwedeng maging, hold on, yung pang K na subscript dun sa sequence, hindi siya pwedeng mas maliit kesa kay K. Kasi nga dapat na preserve yung order. Okay. So ibig sabihin, all right. So if little n is greater than or equal to capital N, and this will work for every term in my original or my parent sequence, alam ko naman yung n sub k, lagi yung mas malaki kay k. Pero kung si k ay piliin ko na mas malaki siya kay n, so ibig sabihin si a sub nk papasok dito sa mga little n's na to. So ang idea dyan, alam natin na halimbawa ito si capital N. Sa lahat ng subscript after capital N, totoo dito yung inequality na AN minus A less than epsilon. Alright? So yun yung sinasabi ng convergence nung AN papunta kay A. Pero kapag pumili ako ng isa pang natural number, say little k, na pipiliin ko purposely, anong tamang term? Pipiliin ko siya with the purpose na mag-guarantee itong inequality. So, meron akong agenda sa pagpili ng little k. Si little k, pipiliin ko na lampas na siya kay capital N. Okay? Kung ito yung pang k na index doon sa parent sequence, then yung pang k na index doon sa subsequence, si little n sub k, ay sure ako mas malaki kay capital N. Because of remark 2.4 na si little k ay laging mas maliit kay little n sub k. Pero ano yung implication na si little nk ay mas malaki kay capital N? Ibig sabihin niya, nag-a-apply itong inequality na to pag yung subscript na n pinalitan ko ng n sub k. Kasi nga si n sub k ay sure ako mas malaki kay k na pinili ko purposely or purposibly or kung ano man yung tamang adverb na mas malaki siya kay capital N. Alright? So that means this inequality is guaranteed with that choice of little k or little n sub k. So therefore, what we have here is that given any epsilon greater than 0, we can select a capital N. Okay. Capital N, such that for all n sub k that is greater than or equal to that starting index capital N, this inequality is true. And that should ring a bell because that is exactly the definition of convergence applied to the subsequence A sub n. So I think that is done. Na-prove na natin na kapag siya ay convergent, alright, pag yung sequence mo ay convergent, kahit ano pang subsequence ang buuin mo, convergent din yon. And not just that, parehas yon ng limit doon sa parent sequence. Alright? Is that clear? Okay, I think it is kasi may nakita at least isang puso kanina. Ayan, dalawa na sila. Thank you. So, now, tingnan natin yung natitira. So, tapos na tayo sa B implying A. Tapos na tayo sa B implying C, sa A implying B. So, yung last na lang, typo ito, hindi ko rin siya na-correct pa rin. C implying A naman. Alright? What is statement C? Titingnan natin yung even at saka odd sequence. Ang sinasabi nitong part CI, kunwari, nagko-converge yung subsequence na may mga even index at saka yung subsequence na may mga odd index. Alright? Then, yun pala, sufficient na yun para makonclude na convergent na si AN. Alright? So, pag kinuha mo yung even, yung odd sequence, parehas silang nag-converge kay A, automatic pala convergent na yung parent sequence kay A din. Which is quite powerful because kung medyo tricky yung pagkaka-define yung sequence, tapos madali kung i-analyze mo siya from the point of view of those with even indices and with odd indices, sufficient pala yon na kapag parehas sila ng limit, convergent na rin yung parent sequence. Alright? So paano natin siya gagawin? Well, same strategy as what I suggested to you guys earlier. Gamitin nyo yung ano yung makukuha nyo mula dun sa assumption. Ano yung assumption natin? Convergent yung odd saka even sequence or subsequence. So gawin ko, okay, wala pa naman ako masyadong alam about convergent sequences, gamitin ko yung definition ng convergence dun sa dalawang subsequence na ito. So doing that, for any epsilon greater than 0, there is a starting index n1 such that etong distance na to ay mas maliit kesa kay epsilon for all of those with with even subscripts. Okay? And then there is another corresponding starting index, probably different from n sub 1. Tawagin natin siyang n sub 2, such that after n sub 2, lahat naman na may mga odd um, odd subscripts, all right, ay makakasatisfy ng inequality na to. Right? And what's our goal? We want to show that the parent sequence will converge, right? Ibig sabihin, dapat makakita ko ng isang starting index kung saan yung A sub n, regardless, even if it's odd or even si n, ay magkakaroon ng distance mula kay A that is less than epsilon. Okay? But that is not hard to imagine kasi ang gagawin ko lang, pipiliin ko kung sino yung mas malaki kay n1 at saka kay n2. Alright? So, halimbawa, ito si N1, tapos kunwari nandito si N2 without loss of generality because otherwise pag baligtarin nyo lang sila, an analogous or a similar argument can be made kung baligtad man yung order ni N1 at saka ni N2, pero yun yung sinasabi natin without loss of generality. Pwede akong maglagay ng additional assumption, but that additional assumption will not lose us yung generality ng proof natin. Kasi it's just a little tweaking of the arguments para mapakita yung kabilang case. Alright? So ang alam ko lang, after N1, okay, lahat ng mga lahat ng may mga even index nakakasatisfy ng epsilon inequality. Tapos right after N2, lahat naman ng may mga odd subscripts nakakasatisfy na nung inequality. And gusto ko mapakita lahat ng terms ng sequence, whether it's odd or even, dapat nakakasatisfy ng epsilon inequality. So the quick fix there is, what if you choose the larger between n1 and n2? Or actually anything larger than both n1 and n2. You can make this your capital N. Kasi sure ka na after capital N, lahat ng may mga subscripts, either it is odd or even, na mas malaki kay capital N, nakakasatisfy na ng epsilon inequality. Alright? So in the minimum, we can select capital N to be the maximum between the smallest even subscript or the smallest odd subscripts for which these two inequalities will hold. Right? Dahil pinili mo na si capital N to be the larger between these two guys, alam natin na right after capital N, mapa-odd or mapa-even man yung subscript, nakakasatisfy na to. So since hindi ko na kailangang i-track kung odd or even yung subscript, tawagin ko na lang yung subscript nila na little n. Right? And that's what we did here. We concluded that the absolute value of a sub n minus a should be less than epsilon. Okay? And again, what we have here, for any epsilon greater than or equal to greater than 0, we can find a capital N such that for all little n greater than or equal to capital N, we have this epsilon inequality. So our conclusion then is that AN converges to A. End of proof. Okay? So theorem 2.6 actually gives us a nice idea how to compute the limit of sequences, even if we don't know kung paano computein yung sequence, yung limit ng parent sequence. Kasi yung statement C ay equivalent kay statement A, so pwedeng tingnan na lang natin yung dalawa niyang convergent sequence, etong dalawang subsequences na to, kung magko-converge sila to the same number. And if that happens, then we are sure that the parent sequence will converge to the same number A. Medyo hindi nga lang madaling gamitin yung A if and only if B. Kasi ang sinasabi nito ay kahit ano daw subsequence ang piliin mo, pag nag-converge si A, magko-converge din yung subsequence. Alright? Pero it is not sufficient to show that just two convergent subsequence will converge to the same number to conclude the convergence nitong parent sequence A. Alright? Unless gagamitin mo yung part C. Okay. Now, even though it's not too much of computational significance for us, yung converse, sorry, not converse, yung contrapositive nung A implying B or B implying A, one of those two will give us a divergence criterion. Kasi ang ginawa natin last time, para ma-prove na divergent ang isang sequence, pinakita natin na walang real number kung saan magko-converge yung sequence. Remember, the alternating sequence, -1 to the power n, pinakita natin na hindi pwedeng 1 yung limit niya, hindi pwedeng -1 yung limit niya, hindi pwedeng real number aside from 1 or -1 yung limit niya. So therefore, kaya natin na-conclude na siya ay divergent, which is a lot of work, right? Especially if you have a more complicated sequence. Now, Theorem 2.6 will give birth to Corollary 2.1. Yung Corollary 2.1 tells us a sufficient condition kung kailan natin mako-conclude yung divergence. Ang sabi niya, kapag ka nakakita ka ng dalawang convergent subsequences, pero nag-converge yung dalawa na yon sa magkaibang limits, then yung original sequence ay magda-diverge. Alright? Which is not very hard to accept. Kasi remember, yung limit siya lamang yung long-term behavior ng sequence. Alright? So pag meron kang kinuhang isang subsequence, tas nag-converge siya kay A, ibig sabihin sa dulo ng subsequence, yung mga elements o yung mga terms nagko-converge kay, halimbawa kay A. So ibig sabihin, merong infinitely many terms, yung parent sequence, na papalapit ng papalapit kay A dun sa dulo ng listahan. Right? So far that's fine. However, if you can find another subsequence that will converge to another number, say B, which is not equal to A, all right? So ibig sabihin, yung pangalawang subsequence, yung mga terms dun sa dulo ng listahan ng pangalawang subsequence na yon, papalapit ng papalapit kay B. Remember, yung mga nandun sa dulo ng listahan ng pangalawang subsequence, sila rin yung mga nasa padulo ng listahan ng parent sequence. So ibig sabihin, merong infinitely many number of terms doon sa parent sequence, dun sa dulo ng parent sequence na nagko-converge naman kay B. So that tells us that there are two conflicting groups in the tail end of the parent sequence. Yung unang group nagko-converge kay A, yung second group nagko-converge kay B. So there is no united behavior para doon sa parent sequence. And basically, that's the definition of divergence. So walang nilalapitang nag-iisang number yung parent sequence as you go along in the list. Okay? Kaya yun yung divergence criterion. Okay? So this provides us an easier way to prove that sequences are divergent. In particular, if we're going to go back to our example, the alternating sequence of 1 and -1, siya ay divergent, but now we will have a neater argument, right? Pag kinuha ko yung odd subsequence, ito yung -1, -1, -1, -1, and so on. It's just a sequence of -1s, and dahil constant sequence yan, nagkukumpulan lang yung mga elements sa dulo kay -1. So this guy converges indeed to -1. Pero pag kinuha ko yung even subsequence, ang makukuha ko naman ay constant sequence ng mga ones. And obviously, that will converge to 1. And here we got two sequences that are convergent, but they converge to different values. So we can conclude that the parent sequence is divergent. And isn't this a neater way kaysa dun sa ginawa natin at the beginning of our discussion about convergence? So yun pala, pwede pala kayo mag-hunting na lamang ng dalawang subsequences na magkaiba yung limit para ma-conclude na divergent yung parent sequence. All right? So I think that's a good. Interrupt nyo lang ako kung may questions kayo doon, but I think that's straightforward. Okay. Now, yun yung isang klase ng pagiging divergent, right? So meron dalawang magkaibang behavior towards dun sa dulo ng listahan. Right? Meron two or more numbers kung saan yung mga terms, may mga grupo ng terms na nagko-converge dun sa isang number, sa kabilang number, and so on. Pero may isa pang klase ng divergence. Posible na merong unified behavior yung entire sequence in the long run, okay? Pero hindi sila nagko-converge sa isang real number. All right? Nagko-converge siya either to positive infinity or negative infinity, right? But we have sort of a layman's idea kung kailan to nangyayari. We say that A sub n converges to positive or diverges to positive infinity kapag habang lumalaki yung subscript, palaki rin ng palaki without bound yung term ng sequence. Alright? Ganon din naman sa negative infinity. So kapag si an nag-converge sa negative infinity, ibig sabihin habang si n ay lumalaki, paliit ng paliit yung number. We are getting a smaller and smaller negative number. Okay? Now, to mathematically state these observations, so itong gusto nating maging definition ng divergence to infinity, we write them this way. Okay? So we say that a sequence diverges to positive infinity, and we write this limit statement here. And I think this is a better statement kasi kung sisimulan natin sa notion na to or sa notation na to, parang sinasabi natin, nag-exist yung limit pero equal kay positive infinity. All right? So it's a little bit, medyo may semantics error dun sa pagsabi, no? Kasi yeah, I can say the limit exists, it's equal to positive infinity. So siya ay convergent, pero kay positive infinity. But we're trying to avoid that, yung posibleng ambiguity na yon from calculus, by saying in the first place na ito ay divergence to positive infinity. And even if it is a divergence to positive infinity, i-adapt lang natin itong symbol na to. Okay? So this is read as an diverges to positive infinity. And when will that occur? It will occur even only if for each real number m, however big it is, we can always find a capital N, a starting index capital N, such that starting from capital N, yung A sub n ay mas malaki na kay M. So ang idea rito, mag-isip ka na ng napakalaking number. Okay? So say 203 billion. Okay? So napakalaki na nung number. Tapos, kung divergent talaga to positive infinity yung sequence mo, ibig sabihin, laging mayroon akong simula kung saan pagkatapos nung index na yon, mas malaki na kay 203 billion yung terms dun sa aking sequence. Right? A similar thing will happen for negative infinity. We can say that A sub n diverges to negative infinity even only if magbigay tayo ng kahit anong real number. Capital M, however big it is, we can always find a starting index such that starting from there, yung A sub n will be less than negative capital M. Ibig sabihin, laging pumili ka ng malaking o maliit na negative number, lagi pa rin may lalampas doon ng mga infinitely many terms ng ating sequence. All right? Now we have example 2.5 here, but example 2.5 is simply an alternative proof for the unboundedness ni n. Kasi sinasabi niya lang, ang limit ng sequence n approaches positive infinity. Pero pag tiningnan mo yung sequence na little n, ito lamang yung 1, 2, 3, 4, 5, and so on, which is basically the set of natural numbers in increasing order, in the natural order. Tapos ang statement na to, ang sinasabi ay dun sa dulo ng listahan, palaki ng palaki yung mga elements ng sequence. All right? And we expect that to happen because we know this is n in ascending order. And we know that n is unbounded above. All right? Now, the proof is here. It uses the Archimedean property. I think this is hindi naman ganun ka straightforward, but I think you can read it on your own. So I'll put example 2.5 as a reading assignment for you guys. So pakibasa at pakiintindi yung proof niya. And let me know on Thursday if you had some troubles working with or reading into example 2.5. Okay. Oh, by the way, which reminds me, gusto nyo pa ba mag-homework? Kasi kung magbibigay ako this week ng homework, hindi ko siya sa inyo mapapapasa next week because next week is already the reading break. Tama ba? Bilis ng panahon, no? Parang kakasimula pa lang ng March and then on Friday, it's already the 1st of April. Okay. Which is the deadline for your reaction papers or your reaction paper for the research webinar. So make sure you submit it right before midnight of April 1. Okay? Tapos April 2 ay reading break na, no? So hooray. After nung paghihirap nyo last week, meron naman pala kayong premyo. Hopefully makapagpahinga kayo ng reading break. And then right after the reading break, Holy Week naman, no? So talagang off kung magbibigay ako ng homework for this week. So is it okay if we don't have homework this week? So siguro magbibigay na lang ako ng homework pagbalik natin after ng Holy Week. Right? I hope that's okay. Kasi kung magbibigay ako ngayon, mapipilitan kayo mag-work ng reading break. Tapos ipapasa nyo siya ng Holy Monday. Tapos ako naman yung mapipersa na mag-check ng Holy Tuesday. Ano? Sa bagay, tama, penitensya ko na yon. Alright? Pero sige, para makapag-relax tayo ng susunod na mga 2 linggo, let's forgo the homework. Tapos alam ko, ayaw nyo ng masyadong maraming homework kasi pag masyadong maraming homework, lumalaki yung denominator, yung bonus na 5 points nung homework 0, na-dilute yung kanyang effect dun sa final grade. Ano? So, sige. Balato ko na yun sa inyo. Right? Okay. Too much kwento na naman. Right. Going back. So, definition ng divergence to infinity. Now, this new concept of limit, all right? Yung limit na equal kay positive or negative infinity, but we know at the back of our minds, that's just a symbol for divergence. But it's a nice kind of convergence. It's a nice kind of divergence because at least we have an idea of what happens in the long term, all right? Kasi sabi natin, ang business natin sa analysis ay ano yung nangyayari sa dulo ng sequence. So kahit mag-diverge siya sa positive infinity, at least we know that in the long run, the terms in the sequence increase without bounds. Palaki sila ng palaki or paliit sila ng paliit, which is a nice thing to know. And kaya natin siya sinusulat as limit equals positive infinity or negative infinity, kahit nga siya ay divergent, kasi maraming theorems involving limits, like the algebraic limit theorems, will still apply. And that's what is written in Theorem 2.7. With the little tweaks here and there, pwede nating ma-adapt yung algebraic theorems natin to allow for at least one of the sequences to diverge to positive or negative infinity. And another thing, the squeeze theorem also extends to infinite limits. And in the sense that if you are given a sequence and you can think of two sequences, AN and BN, that can sandwich between them yung sequence mo na CN, tapos nagkataon na yung AN at saka yung BN na ay nagda-diverge parehas to the same kind of infinity. Either they both diverge to positive infinity or they both diverge to negative infinity, then the middle sequence, yung CN, magko-converge din siya to the same brand ng infinity. Yun yung ibig sabihin dito ng extension ng squeeze theorem sa infinite limits. Tapos ganun din yung sa algebraic theorems. Okay? Kaya it's still very handy to write divergence to infinity in terms of the limit symbol. Kasi nga, na-inherit pa rin niya or nahahawa siya dun sa property ng limits. Actually, it's also a preparation once you extend your numeration system to allow for the positive and negative infinity to be treated as numbers themselves. Okay? Pero hindi natin yung gagawin sa 155, hindi natin isasali yung plus or minus infinity. Kasi ang tawag na doon ay the set of extended real numbers. Pero now we will confine ourselves to the real number system. Okay? Now, tingnan natin. Ano yung sinasabi nitong Theorem 2.7? Meron akong 2 sequences. Yung una, yung AN, nagda-diverge siya to positive infinity. Okay? And then, ito yung isa sa mga theorem, part ng theorem. Kapag ka daw si Bn ay bounded below, then the limit of the sums. So kunin mo yung sequence consisting of An plus Bn. Pag kinuha mo yung limit niya na sen approaches infinity, magda-diverge siya sa positive infinity. That is with assumption that An diverges to positive infinity. Okay? Pero if you think about it, yeah, that's kind of natural because kung si AN ay palaki ng palaki in the long run, tapos dadagdagan ko siya ng BN, then most likely AN will drive the day. Yung behavior ni AN, yung mangingibabaw doon sa behavior ng AN plus BN. Bubuhatin ni AN yung sequence BN papunta sa positive infinity. Right? But there's a little caveat here. There is an additional assumption. B sub n must be bounded below. Right? Can somebody tell me bakit kaya? Or can you speculate, bakit kaya kailangan bounded below si Bn? Hindi ba pwedeng pabayaan ko na at sabihin ko na si Bn ay kahit anong sequence? Ano yung magiging problema kapag ka si sequence Bn ay hindi bounded below? Sige nga, bakit kasama yan sa assumption? Okay, Charles's idea is spot on. Thank you, Charles. Ang sabi ni Charles sa chat ay, kasi posible na mag-approach sa negative infinity naman yung Bn. So kung mag-diverge to negative infinity yung Bn, ibig sabihin hindi na natin alam kung sino yung mananalo sa kanilang dalawa. Alright? Because we might end up with a case of an indeterminate form. Alright? Kasi magano yan, merong magiging push and pull between the behavior of AN and BN, and we are not sure which will prevail in the end. Okay? Kasi maglalabanan na ng rate of convergence yung AN at saka BN. So hello sa mga nagwa-175 dyan, rate of convergence, di ba? O sino yung mabilis mag-diverge dun sa positive or negative infinity. Kung mas mabilis nag-diverge yung AN, so yung AN plus BN mabubuhat papuntang positive infinity. Pero kung significantly mas mabilis yung pagda-diverge ni Bn, yung An plus Bn magda-diverge kay negative infinity. Now, if they will diverge at around the same level or proportional yung rate of convergence nilang dalawa, then this will be a constant. And we're not sure what that constant would be. All right? Ito yung indeterminate form sa function of real variables natin na plus infinity minus, infinity minus infinity. So indeterminate siya. Okay? Now, there are analogous results here pertaining to the other cases, and they are really kamukhang-kamukha nung algebraic theorems natin. Perhaps let's just prove part 1. Okay? Okay. Or sketch the proof at least of part 1. Ano ba yung sabi sa part 1? Sa part 1, si AN daw nagko-converge to positive infinity, tapos si BN ay bounded below. Okay. Ang alam natin dito ay si AN for any choice of real number m, there exists a natural number n, a starting index, such that after that starting index, all right, yung AN ay mas malaki na kaysa dun sa pinili nating real number kanina. And again, this is just a definition of divergence to positive infinity. I just wrote it here para mag-guide ako kung paano ko isusulat yung proof. So you can treat this as my preliminary analysis. Okay? Tapos si Bn daw ay bounded below. So ibig sabihin, there exists a, say, m sub 0 such that, tawagin kong m1 yung nandun sa taas. Okay? Tapos tawagin kong m sub 0 naman yung lower bound para kay Bn, such that Bn is greater than or equal to m0 for all n. So ito yung alam natin so far mula dun sa ating definition. Okay? Now, what do we want to show? We want to show divergence to positive infinity. So we want to show that for all real number m, Okay? In R, there exists a starting index such that starting from capital N, okay, yung AN plus BN dapat ay mas malaki na kay M. Alright? So ito yung gusto nating ipakita. But how can we do it? Now, you compare what you want to show with what do we have so far from the assumptions, okay? Oh, alam ko yung BN, lagi siyang mas malaki kaysa kay M sub 0. So I can replace this guy by a smaller number, right? And that smaller number would be M sub 0. Okay. So alam ko ito ay magiging less than kasi pinalitan ko yung BN ng mas maliit na number. Okay. Now, if I'll be able to find a smaller number than AN, at least for sufficiently large subscripts little n, then we are done. I'll just take my capital M to be an arbitrary number related to this sum. Okay? Pero ano yung pwede kong mabigay? Ano yung magiging bound para kay AN? Well, luckily, we already know that what that is. Kasi after some point, magkakaroon ako ng M1, magkakaroon ako ng terms sa sequence. Actually, lahat ng terms ng sequence after capital N, all right, ay mas malaki na dun sa M sub 1. And this is true for all M sub 1 na real numbers. So, lagi akong may makikitang starting index na yung A sub N ay mas malaki na kay M1. And if that happens, then I know that this sum is greater than M1 plus M sub 0. Right? Now, will this suffice as a nice choice for capital N or for us, kasi dapat magawa natin to for all capital M, right? Kasi yun yung sinasabi, for all capital N, dapat may mahanap tayo na starting index. M sub 0 is fixed because it is one of the lower bounds nung sequence BN. Hindi to arbitrary kasi existent siya. Alam lang natin may nag-exist pero hindi lahat ng real number totoo ito. So, yeah, medyo kabado tayo kasi existence lang yung meron ako gusto ko for all M. Ito yung iniisip ko sa capital M. But we will be saved by the arbitrariness, may word ba na arbitrariness, o ng pagiging arbitrary ni M1. Because this will be true for any M1. We can choose M1, all right? We can consider any M1, arbitrary si M1. So yung M1 plus M sub 0 will still be arbitrary. Pero kahit arbitrary si M1, lagi akong may makikitang capital N such that this is true. So in turn, pag nagkaroon ako ng arbitrary number M1 plus M sub 0, I can find a starting index for which A sub n plus B sub n will be greater than M1 plus M sub 0. And that's how I intend to write the proof. So I will construct it in such a way that this guy will act as our capital M. Right? So yun yung idea, yun yung sketch ng proof. Ito yung hindi ko pa pala yung napapagawa yung pagsusulat ng sketch ng proof. Kasi posibleng yung preliminary analysis nyo ay kamukhang-kamukha na ng proof na isusulat nyo. Or the meat really is not on the actual proof but on the preliminary analysis that you did. And usually a sketch of the proof will suffice even if especially if formalizing the actual arguments will be a tedious process. Isa yun sa mga pinaka-hate ko na exam dati sa 155. Kasi mahilig yung teacher namin, sketch the proof of. So, sulat ka lang, magkikwento ka lang. Kaya lang naman minusan ako ng 1. Kasi usually, napaka-detalyado daw nung sketch ko ng proof. Hindi na daw siya sketch ng proof, pero siya na yung actual proof. Kaya medyo ayoko nung sketch the proof lamang. Alright? Kasi nabibiktima ako. Nasusulat ko daw yung buong proof. Ang hindi lang alam ng teacher ko, na pag ang instruction niya ay prove the following, alright, ay mas mahaba pa doon yung proof ko, alright? Kasi super detalyado yung mga proofs ko. Na minsan kahit obvious siya, sinusulat ko pa rin. So, shout out kay Sir Ariel. Siya yung teacher ko sa 155 noon. Pero anyway. So, going back sa proof. Alright. So, yun yung idea natin sa proof. So, simulan ko dun sa pagpili ng specific specific m sub 0. So, note that since B is bounded, or is bounded below at least, then we know that there exists a specific real number. Let's call it m sub 0, such that B sub n is greater than or equal to m sub 0 for all natural number n. Okay, that's fine. And then now, gagamitin ko naman yung sa divergence naman to positive infinity nung isa. So we will let m to be an arbitrary, m ba gagamitin ko? Hold on. Okay. Let m be an arbitrary real number. Okay. Then, since a sub n diverges to positive infinity, then there exists a starting index capital N such that whenever little n is greater than or equal to capital N, then a sub n will be larger than that arbitrary real number m. But I can play a trick here. Katulad ng trick natin dati na kapag ka meron kang definition ng limit, tapos meron kang for all epsilon, di ba? So pwede nating piliin yung starting index para yung inequality merong epsilon over 2. Kasi yung epsilon over 2 naman ay positive real number pa rin. Yun yung kagandahan ng pagiging arbitrary nung nandun sa final inequality. Now, I'll use a similar trick here, but I want a sub n to be greater than an arbitrary real number, but that arbitrary real number is not exactly m, but another arbitrary real number that will involve m. And I will choose it to be, any hula, ano yung gagamitin ko rito sa inequality? Nakita ko na sa preliminary analysis na in the end, I will have m1 plus m sub 0 to be a lower bound para kay an plus bn. Alright? Pero ito yung tatawagin nating m para masunod yung definition dun sa gusto nating i-prove. So I want this to be essentially true, right? So here I'm gonna choose m1, the upper bound, to be malapit na yung hula mo, Jonathan, right? Pero ang pipiliin ko ay actually hindi. Yeah, tama ka pala, Jonathan. That's right. M minus M sub 0. Siya yung pipiliin ko na M1. Bakit siya yung pipiliin ko na M1? Kasi alam ko in the end, yung M1 plus M sub 0, dapat siya yung maging capital M para sa definition ng divergence to infinity nung AN plus BN. So, alam ko to. So, pag sinob ko si M1 dapat ay M minus M sub 0. And this is still fine because this is still an arbitrary real number. Ang condition lang sa divergence to infinity, m should be a real number. So ito, real number pa rin yan kasi it's a real number minus another real number. Okay? Ito yung pagiging binary operation ng addition of real numbers. Okay? Now, so thus, okay, ang a sub n plus b sub n ay greater than, okay? Alam ko na kapag ka si little n ay mas malaki kay capital N, alam ko yung an ay mas malaki kaysa kay m. Tanggalin ko muna yung inequality. Tapos, si bn, alam ko kahit ano pa man yung subscript na n, mapamaliit o mapamalaki, mas malaki yung kay m sub 0. Okay. So this guy was replaced by a smaller number. Its addend is also replaced by a smaller number. So in effect, the original sum is greater than the smaller sum. Sorry, not malamang is greater than the smaller sum. It's greater than the second sum. All right? Sorry. Kulang pala. This is m minus m sub 0. Ito yung pamalit kay an plus yung pamalit kay bn, which is m sub 0. And this guy simplifies to capital M. So again, review. Ano yung meron tayo? For any real number M, there exists a starting index capital N such that right after that starting index, yung A n plus Bn ay greater than kay M. So basically that means A sub n plus Bn diverges to positive infinity. End of proof. Okay. All right. So yeah, that's the proof and our translation from the preliminary analysis papunta dun sa formal proof. Now try the other the other parts of the theorem. Though dun sa lecture notes nandiyan na yung para kay B. All right. Tinakluban ko lang siya para mag-prove live. Okay. So you can read the proof for 2, but it will also be nice to try it on your own. Apply the ideas that we also did for part 1. I think they will hold, or at least a similar argument will hold for parts 2, 3, and 4. So that should be fine. Okay. And try some exercises here. Some of them are computational. But again, I'm not dwelling too much in the computational aspects of sequences. Kasi pang math 30, saan nyo ba ito na-meet? 38, all right? So mas gusto ko yung kanilang theoretical significance. Okay. Now, let's move on and consider probably the first big name in sequences. All right. Actually, hindi pala ito yung first big name kasi meron na tayong squeeze theorem, right? Pero hindi siya usually sinasama dun sa mga big names. But I consider the squeeze theorem as a nice consequence of completeness. And I'm not sure kung tama yung pagkakalala ko, parang equivalent din ng squeeze theorem sa completeness. But I need to check that. Okay. Pero itong isang to, I'm sure that this is equivalent to completeness. So ano yung theorem na to? But before there, ang motivation dito ay yung example pa rin natin ng alternating sequence negative 1 to the power n. Okay. Remember, there is a result that told us that kapag ka meron kang convergent sequence, automatic siya ay bounded. So convergence implies boundedness. Okay? Tapos, ang natural thing to do kapag ka naka-establish ka ng isang theorem na conditional, ang susunod mong isipin, baka naman pwedeng if and only if to. Kasi mas powerful yung if and only if statements. So usually sa math, gusto natin makabuo ng mga if and only if statements because they are characterizations, they're alternate definitions, and they are pretty elegant. Okay. Now, tanong mo ko yung converse side to. Yung theorem, convergence implies boundedness. Yung converse, bounded implies convergent. Question, is that true? Well, if you think of, say, meron ba tayong example ng bounded na convergent? Yes, yung mga constant sequences. So yung mga constant sequences, sila ay bounded. Alright? Kasi nga, constant lang naman yung laman niya, hindi nagbabago. So mako-contain natin siya sa kahit anong open interval containing the constant term. Okay? Kaya lang, sa math, pag sinabi natin na true, dapat true siya for all. Wala ritong versions ng truth. Walang kanya-kanyang facts dito, right? So it will be true if it is true for everyone. Kung hindi siya true sa isang case, false na siya dapat. All right? So, kapag pag nakakita ka ng isang instance that the converse is false, then you can say with finality that the converse is false, even if it will work only for one specific case or kung false siya sa isang specific case. Now, the bounded sequence, negative 1 to the power n, will serve as our counterexample for the converse. Kasi itong sequence na to, ang laman niya lang ay plus or minus 1. So definitely bounded yan. In particular, it's bounded by the closed interval it is inside a closed interval negative 1 to 1 or any superset of that set. All right. So bounded ito. Pero napakita natin by the divergence criterion and even using a brute force proof na ito ay divergent. So nakakita tayo ng isang bounded sequence na divergent. So false sa kagad si converse. Pero hindi ka titigil doon as a mathematician. Isipin mo, meron kaya akong pwedeng idagdag sa boundedness para makonclude ang convergence? Kasi usually, ang mas ano sa atin, ang mas interesting ay yung mga convergent sequences. So what needs to be added or what is sufficient to be added to boundedness to guarantee convergence? And that's what the monotone convergence theorem is telling us. But before discussing the theorem, kailangan muna nating malaman ano yung pagiging monotonic. O ano yung isang monotone. Okay? So first, yung isang sequence, i-define lang natin properly kung kailan siya increasing. A sequence is increasing if a sub n is less than or equal to a sub n plus 1 for all little n. So kapag ka yung n term ay less than or equal to sa n plus 1 term, then siya ay increasing. Okay? So ibig sabihin, pagka walang ibang posibleng direksyon, kundi pataas or palaki ng palaki yung values, habang palaki ng palaki yung index, siya ay increasing. And then if you can drop the equality symbol from the inequality, nagawang strict less than na lang siya, then that's what we call a strictly decreasing sequence. And then analogous definitions can be made for decreasing and strictly decreasing sequences. Okay? So yun yung pagiging increasing or decreasing. Now, if your sequence is either increasing or decreasing siya, ibig sabihin, isa lang yung behavior. Either palaki ng palaki yung mga terms or paliit ng paliit yung mga terms. Ang tawag natin doon ay monotonic sequences. Right? So yung monotonic, yan yung adjective natin para doon sa sequences. Okay? So kaya ang prefix niya ay mono. Ibig sabihin, isa lang yung behavior niya. Isa lang yung behavior, either increasing or decreasing lamang siya all throughout. Now, -1 to the power n obviously is not monotonic kasi from -1 to 1 nag-increase siya, pero from 1 to -1 nag-decrease siya. So from A1 nag-increase siya to A2, pero from A2 nag-decrease siya to A3. So ibig sabihin, walang nag-iisang behavior yung sequence, so hindi siya monotonic. Okay? Now, it turns out that kung meron kang bounded sequence, i-require mo lang na siya ay monotone, then automatic siya ay convergent na. So basically, monotonicity, yun yung noun para sa, noun ba yun? Yeah, yung noun para dun sa monotonic, ay isang sufficient condition na pwedeng idagdag sa boundedness para ma-conclude yung pagiging convergent. Okay? Now, let's try to write a proof for theorem 2.8, which is basically called the monotone convergence theorem or MCT. Okay. Usually gamit na gamit din yung MCT because it is a very convenient way of showing convergence because all we need to do is to check for boundedness, which is usually easy by just looking at the terms of your sequence, right? Or the first few elements thereof. Madali siyang i-imagine. Tapos yung monotonic naman is an algebraic or a calculus exercise. Kasi kailangan lang nating ma-establish yung inequalities na yan. Okay? Now, let's try to write a proof. Okay. Proof. Okay. Now, for the proof, I'll consider a monotonic increasing sequence that is bounded. And you see here that I am including the assumption that the sequence is monotonic increasing. Pero dun sa theorem, ang assumption lang ay pagiging monotone. Ibig sabihin, if I start my proof here, I am expected to say something about yung pagiging decreasing naman ng sequence. Kasi nga, ang usapan lamang, yung assume mo monotone siya. Right? Either monotonic increasing or monotonic decreasing. So, kung sisimulan ko yung proof dito, I should have a remark, all right, dun sa dulo ng proof para naman sa decreasing sequence. Ito yung ginawa nung iba sa inyo in the problem set. They forgot to mention something about what happens kasi inassume nila yung infimum ng A ay less than or equal sa infimum ng B. Ito yung sa isang problem sa problem set. Nagawa sila ng proof which looks nice, all right? But they forgot to mention that analogous arguments can be made if the infimum of A is greater than or equal to infimum of B. Just to complete the thought of the proof, all right? Kaya hinahanap ko yon. Pero hindi na yata ako nag-minus. So, kung na-minusan ko kayo, just let me know, tatanggalin ko yung minus. Kasi naging mabait na ako nung Sunday. Alright? Hindi na ako nag-minus kung nakalimutan man yung statement na yun. It's not a big deal, pero for the completeness of the proof, it's nice to include that notion, okay? Or that remark. Okay, so nagsimula ako sa monotonic increasing sequence that is bounded. Okay, boundedness. What does boundedness tell us? Kung siya ay bounded, ibig sabihin yung sequence sa iyan ay bounded above and below. Alright? So that means, dahil siya ay bounded above and below, meron siyang upper bound. Kung meron siyang upper bound, kasi sequence siya of real numbers, meron siyang least upper bound. So that means, by the LUB property or the completeness axiom, right? The supremum of A exists, and let's call it little a. Tawagin ko siyang little a. And then my claim here is that wala nang ibang mas magandang hula sa pagiging limit ng sequence, all right, than the supremum A. And it's not hard to imagine why, kasi kung meron kang isang sequence na bounded, doon siya sa loob ng isang closed interval, nandito si A1, tas monotonic increasing, A2, A3, A4, A5, kasi nga monotonic increasing, A6, and so on. Tas meron siyang supremum, okay? It seems that magkukumpul-kumpulan na dito yung mga ANs. So, ibig sabihin, habang lumalaki yung subscript, dapat palapit ako ng palapit sa supremum. And I know that I cannot go beyond the supremum because the supremum is the lowest or is the least upper bound. So, hindi talaga pwedeng lumampas yung mga terms ng sequence dun sa supremum kasi in the first place, it's an upper bound. Isipin nyo na lang, ito si Gandalf. Sabi niya dun sa mga nasa dulo ng sequence, you shall not pass. Alright? So, hindi siya lalampas doon. Ang corny, napaka 90s nga ba ang Lord of the Rings? Pero timeless naman siya. So, walang hulaan ng edad dito. Alright. So, that's my claim. My claim is that A sub n will converge to the supremum A. Okay. Now, how do we do this? Well, I want to establish the inequality involving this guy, all right? So for any epsilon greater than 0, I should find a starting index, capital N, such that right after that starting index, this inequality is true. And if I'll be able to do that, then really proven na yung theorem, na converge na siya kay A. Now, paano ko siya gagawin? Well, it should involve an arbitrary epsilon greater than 0, tapos meron akong supremum. Ano yung may result ba tayo na magkasama yung supremum at isang arbitrary epsilon? The answer is yes. We do have what we call the characterization of the supremum, right? Kasi nga siya yung least upper bound. So ibig sabihin, for any epsilon greater than 0, there exists an index n such that si A sub n ay magiging mas malaki na kay A minus epsilon. Kasi sabi ng characterization ng supremum, kung ikaw talaga si supremum, pag binawasan kita ng kahit gaano kaliit, hindi ka na magiging upper bound. Alright? So that means kung hindi na siya upper bound, si A minus epsilon dapat ay mas maliit na sa isang term ng sequence. At least isang term ng sequence. Tama? So merong isang term ng sequence na mas malaki na sa kanya, kaya disqualified na si A minus epsilon from becoming an upper bound. Right? Characterization ng supremum. Okay. But this is not what I really wanted. I want to show that for any epsilon, which is fine, okay, na ipasok ko na yung arbitrary epsilon, kailangan magkaroon ako ng starting index. Oops, may starting index na, kulang na lamang magamit ko yung little n. Alright? Kasi yung definition, dapat little n yung nasa inequality. Alright? Now, how can I introduce little n? Well, meron pa akong isang hindi nagagamit. Aside from yung panghuhula ko ng supremum may equal dun sa limit. Alright? Hindi ko pa nagagamit yung pagiging increasing nung sequence. Alright? Now, gagamitin ko siya. So, and I am now hoping here and praying na ito ay ililid ako dun sa tamang landas. Right? So, gusto ko magamit yung increasing pero tanda ko sa definition ng limit, kailangan ko magkaroon ng ganito, little n greater than or equal to capital N. Okay. Pero ano yung gusto kong gamitin? Yung pagiging increasing ng sequence kasi siya pa yung assumption na hindi ko nagagamit. So kapag ka ito, ang motivation ko dito, definition ng limit. Pero luckily, I know that this means that a sub n, all right, will be larger than or equal to a sub capital N. Kasi nga increasing si an. Pag mas malaki yung subscript mo, mas malaki yung value mo. All right? But what do we know? I know that a sub little n, a sub capital N is less than a minus epsilon. All right? So yan na yung alam ko. Actually, I know more than that. Okay? I know that a is the supremum. So in the first place, it is an upper bound. So I know that a sub little n, whatever little n is, that will still be smaller than the supremum a. All right? Kasi nga si a ay upper bound in the first place. Tapos kung upper bound na si a, dagdagan ko pa siya ng epsilon, sure na ako na mas malaki yon kaysa kay a. And then I'll just reduce this long continued inequality that we have into the more familiar form that what? A minus epsilon is less than a little n is less than a plus epsilon. And then I'll just add a to all sides and get negative epsilon less than a sub n minus a less than epsilon. Definition of continued inequality, absolute value ng an minus a less than epsilon. And then quick review, for any epsilon greater than 0, we were able to find a capital N starting index such that right after that starting index, the epsilon inequality is true. So therefore, we can conclude that A sub n converges to A. End of proof. Okay? And this proof is nice because it did not just tell us that the sequence is convergent. We were able to give something more than what the theorem required. Ang nakita pa natin dito, magko-converge siya doon sa supremum. Okay? Hindi lamang siya convergent, pero we're saying more. Medyo pabida yung proof. Ang hiningi lang, proof of convergence, pero sinabi pa natin, magko-converge siya doon sa supremum. Actually, hindi pa pala tapos yung proof. You can say here that analogous arguments can be made if blah blah blah. Ano yung blah blah blah? If yung sequence na kinonsider mo ay monotonic decreasing. Now, bakit analogous arguments? Kasi kailangan mong baguhin ng konti yung approach. Okay? Paano mo siya babaguhin? Kung monotonic decreasing siya, so siya ay bounded below. Kung siya ay bounded below by a consequence of the LUB property, meron siyang infimum. Tapos ang claim natin, yung AN magko-converge dun sa infimum. Tapos ang characterization ng infimum, kapag ka meron kang epsilon greater than 0, pag dinagdag mo siya dun sa infimum, hindi na siya magiging lower bound. So the inequalities will just be flipped. You'll use the decreasing property of the sequence para makuha yung baligtad namang inequality dito, but essentially, you will get the same conclusion. Okay? So try to write it, and it's a nice exercise, a review exercise, para makita nyo kung nakuha nyo yung meat netong proof na to, ay isulat from memory or on your own later yung proof para naman kung monotonic decreasing yung sequence. And if you will be able to do that, then you understood the essence ng proof ng Theorem 2.8. And now we're starting to build towards looking at the big names and sequences or the big theorems in sequences. Kasi kung makikita nyo, the central idea behind the proof of the monotone convergence theorem is the concept of completeness, yung LUB property. So basically, ito yung meron na tayo ngayon. Meron ko tayong Dedekind's completeness. Via remark, we said that this is equivalent to the LUB property. As sabi natin, we can elect either of them as our completeness axiom. And then we have proven the Archimedean principle coming from the LUB property. And then, ano pa ba yung mga properties ng Archimedean principle? We have a couple more properties, consequences of the Archimedean principle. Pero I think ang sumunod ng big name natin ay ito ng Monotone Convergence Theorem. And the Monotone Convergence Theorem was proven to be using LUB property. So pwede natin ditong ilagay yung MCT. All right. Tapos after MCT, on Thursday, we're going to look at the nested interval property. Pero yung nested interval property, makikita nyo na siya ay mapoprove using the monotone convergence theorem. So basically, it's MCT implying NIP. Tapos after ng NIP, magkakaroon tayo ng Bolzano-Weierstrass theorem. Okay. Tapos after Bolzano-Weierstrass theorem, ipoprove natin yung Heine-Borel theorem. Actually, may isa pa pala before Heine-Borel. I'm not sure if it's before Heine-Borel or before Bolzano-Weierstrass. Pero meron pa ritong Cauchy convergence criterion. Tapos siya yata yung gagamitin ko sa Bolzano-Weierstrass o the other way around. Tapos after Bolzano, we're gonna look at the Heine-Borel theorem. So ito yung ating multiverse ng completeness axiom. Alright? So unti-unti nang dumarami yung nasa listahan. Luckily for us, hindi natin kailangang i-prove yung equivalence ng mga yan. It's for a graduate course, alright? Pero imagine yung pinagdaan ng campaign, pag-iisip ng equivalence na yan. Kasi sanga-sanga yung ano niyan, sanga-sanga yung arrows. Hindi katulad nung yung equivalence natin ng Theorem 2.6 na triangle lang yung cycle, okay lang siya. Pero dito sa proof na to, tingnan nyo kagad to, yung Archimedean principle, nakahiwalay na. So I need to incorporate the Archimedean principle somewhere in this diagram para makompleto pabalik dun sa Dedekind's completeness. But it's a nice exercise to map these things out para kung magma-masters kayo, may idea na kayo ano yung mga equivalent sa completeness axiom. All right? But that's for the future. So hopefully on Thursday, we finish actually apat pala yung theorems natin on Thursday. Okay. The NIP, the Cauchy convergence criterion, the Bolzano-Weierstrass theorem, and the Heine-Borel theorem. So sige, tingnan natin. Tuesday. All right. So siguro, we'll try our best to finish as much as we can on Thursday. Pero kung hindi natin siya matapos, siguro ipapa-watching assignment. Parang ang weird sabihin ng watching assignment, pero okay lang yung reading assignment, no? Ano ba tamang tawag doon? Siguro binging, basta. Papapanood ko na lang sa inyo yung video ng lecture ko last semester about yung mga theorems na hindi natin matatapos sa Thursday para hindi na natin kailangan mag-meet sa Holy Tuesday. Para dire-diretso na yung pahinga nyo. Alright? And then we'll just meet each other again after the Holy Week. Tapos babawi ako ng homework pagbalik natin galing sa Holy Week. Alright? So I think that's fine. Okay? Do you have any questions, reactions, comments, suggestions, whatever? So kung wala na, so I hope you guys enjoy the rest of the day and then kita-kits ulit tayo on Thursday. Bye everyone.